Hello, you're welcome to Young Maths Academy. Today we'll just continue our class on bearing and distances. The last lecture we started the introduction to bearing and distances. So today we have a question on the board. The point A is 20 kilometers from B on a bearing of 0.65 degree. Calculate correct to one decimal place the distance of A to north of B, B east of B. So now, to attempt this question, you need to know that all questions in bearing leads to formation of a triangle. Solution. So a point A is 20 kilometers from B. So I'll create my four cardinal points: north, south, east, and west. Here, from B means it's coming from this point here. So it is on a bearing of 0.65 degree. So I'll create a small arc and draw a line this way. 0.65 degree. 20 kilometers. That's the distance. 20 kilometers. So A is 20 kilometers from B. So this point here is point A. North, south, east, and west. So at this point, this is A. Now the question says calculate correct to one decimal place the distance of A to north of B. So this is the north of B, means I have to create a kind of broken line. You can draw a broken line this way and join it with this. So it means that I am to look for this distance here. So let me name this X. Let's call this C. This can be called C. Also, it says we are to find to one decimal place the distance of A east of B. Implies that I can also create this the east of B, means I have to join this or create a broken line this way and join it at this point here. So if you look at this very well, it will create a right angle here. Also, there's a right angle here. A right angle here. Very good. So let's call this angle here theta. Okay, let's attempt our first question, north of B. Now to get that, we make use of our trig function since it is a right angle triangle. This is the unknown we are looking for. The angle in this triangle here is 65 degrees. So we use our trig function sine 65 degrees is equal to the opposite of the angle over the opposite, which is x, over the known side of hypotenuse. That's x over 20. So we have that x implies that x is equal to 20 sine 65 degrees. Okay, so 20 sine 65 degrees. At that point, if we check our calculator, 20 sine 65 degrees, we obtain 18.126. 18.126 kilometers. But we are told in our question to take it towards one decimal place. So since we have to take this to one decimal place, it becomes 18.1 kilometers to one decimal place. Okay, we've been able to find the distance of A to north of B. Now we want to obtain the distance of A to the east of B. Okay, implies that to look for this portion here, I can name it Y. This side length here, I can name it Y. So to get that, before we can obtain that, we need to get this angle. We already know that each of these quadrants here holds a 90 degree. So at this point is 90 degree, implies that to get this theta, it will be 90 minus 65. So 90 minus 65 will give us 25 degree. 90 degree minus 65 degrees, 25 degrees. So now we can find the side length Y. To get the side length Y, we also use our trig function. This is the unknown opposite over the known opposite of hypotenuse, that's sine. So sine 25 degrees is equal to Y over 20. So that at this point we have Y is equal to 20 sine 25 degrees. So Y is equal to, if we check our calculator, and that gives us 8.45. So 8.45 kilometer, but to one decimal place we have that y is equal to 8.5 kilometer. So this is how we tackle questions like this, and you can subscribe on the channel. Subsequent lectures will continue and take further examples on tougher questions on bearing on distances. Thank you.